Hello, nerds. I hope you guys are having a great day. This is the last chapter of Advanced Geometry. You should be pretty excited. The school year is coming to an end pretty soon. And of course, we saved the best for last. This actually is one of the most applicable things that you'll use in your future math classes. So sadly, I'm going to try to teach this to you online, and I'll do the best I can. But I'll also provide you some resources so you can get extra help. Khan Academy does some good videos about trig ratios as well, and I'll have those linked on the Schoology page. So the first thing is just a video of introduction. This isn't notes or anything. It's just me trying to explain to you the big picture concept of what the heck trigonometric or trig ratios are. All right, and there are three trig ratios that we're going to study in this unit. You can see them at the top of the screen here: sine, cosine, and tangent. All right, so before we get there, though, let's just talk about in general about what we know about a right triangle. So you guys will notice here in this diagram, I have two right triangles, and those two triangles, in fact, are similar to one another, and I know that because of angle-angle similarity. Notice how they both have a 40-degree angle, and they both have a right angle. And there you go. Two pairs of corresponding congruent angles means the triangles must be similar. All right. Now, the reason that is important is because, as we know, if the triangles are similar, then the ratios of any of their side lengths are similar. All right? And so in just a minute, I'll explain where that comes into play. So the first thing is when you have a triangle, there are two acute angles here. There's angle A and there's angle B. And then we have, like I said, in a right triangle, you have a right angle. So when we're talking about our trig ratios, we're always going to be talking about them relative to one of the acute angles. So in each of these examples, I'm going to talk about my trig ratios relative to angle A and angle D. All right, so let's talk about angle A. Here's angle A chilling in my triangle, and there's a 40-degree angle. All right, and I just arbitrarily chose 40. It can be any acute angle measure whatsoever. All right, now, relative to this angle, there are three sides to this triangle. Now, the obvious side that never changes is the hypotenuse. The hypotenuse is always the side that's directly across in that right angle. It is the longest side of that right triangle. All right, now, but if I'm referring to this acute angle, angle A, well, then there are two legs relative to that angle. There's this leg that's opposite it. It's across the other side of the triangle. This leg is opposite to angle A. All right, so we call it the opposite leg. This leg that touches angle A is adjacent to it. Adjacent right next to, so this is the adjacent leg. And it is important that you understand, relative to a given angle, which side of the triangle is the opposite leg, which side is the adjacent leg, which side is the hypotenuse. And you can see down here as well, if this is my 40-degree angle, angle D, the angle I'm dealing with, relative to it, we have the opposite side, the adjacent side, and the hypotenuse. All right, so now that we can look at a right triangle and identify what sides are what relative to a given angle, let's talk about how these trig ratios work. So the first step to this is I'm going to show you the different side lengths to these triangles. All right, so in the blue triangle up here, we have that the adjacent leg, AC, is 6.38 centimeters. The opposite leg, which is segment BC, has a length of 5.35 centimeters, and so forth and so on. So you can see the lengths of the blue triangle here. You can see the lengths of the green triangle here. And what you can see is that they are different lengths. All right. So, but we do know if the triangles are similar, then like the ratio of this adjacent leg to this adjacent leg would have to equal the ratio of this opposite leg to this opposite leg, and so forth and so on. And because that is true, because in the similar triangles, the corresponding sides are proportional to one another, that means that within one of these given triangles, any pair of corresponding sides would have to be into the same ratio with the sides that correspond to them here. So I know that's kind of hard to grasp, so let me just show you what I mean. So here are all the different side lengths for the blue triangle. Here are all different side lengths for the green triangle. And now let me show you the ratios, or if I divide those side lengths, what I get. So in this blue triangle, if I take the opposite leg and I divide it by the hypotenuse, I get 0.64. And you'll notice that in the green triangle, because they're similar and their side lengths are proportional, if I take this opposite leg and divide it by this hypotenuse, I get the exact same ratio. And when I do the same with the adjacent and the hypotenuse, I get 0.77. And in the green triangle, I also get 0.77. And for the opposite over adjacent, I get 0.84. And for the opposite over adjacent here, I get 0.84. So the point I'm trying to make is that because these triangles are similar and their corresponding sides are proportional, regardless of the size of those triangles, if I take their different sides and divide them, I will always end up with the same ratio because of that similarity. So what that means is that for any triangle that has a 40-degree angle, if I take its different side lengths and divide them, or right triangle I should say, if I take any of their side lengths and divide them, I'll always end up with these ratios. It doesn't matter the size of the triangle, but if it is a right triangle with a 40-degree angle, every single time the opposite leg divided by the hypotenuse has to be 0.64. And every single time the adjacent leg divided by the hypotenuse has to be 0.77, and so forth and so on. So in a right triangle, if I just know one of those acute angle measures, I guarantee to know what all the ratios of the sides divided would be. Right now, so the next step was what does all of this have to do with these words sine, cosine, and tangent? So the next thing I'm going to show you is I've already calculated these, but now I'll show you on the screen the trigonometric ratios for this triangle. So check this out. In this triangle, the sine ratio, which I know you don't understand what that means yet, is 0.64. Now I want you to notice, opposite of hypotenuse was 0.64 as well. The cosine of the measure of angle A, the cosine of this 40-degree angle, is 0.77, and I want you to notice that the adjacent over the hypotenuse was 0.77 as well. And then finally, the tangent of this measure of angle A is 0.84, and we found that if you divide the opposite by adjacent legs, you get 0.84. So what this shows you is the definition of what all these trigonometric ratios are. Sine is simply the opposite leg divided by the hypotenuse. Cosine is simply the adjacent divided by the hypotenuse. And tangent is simply the opposite divided by the adjacent. So here's what I know. I know that any right triangle that has a 40-degree angle, no matter how big it is, if I take its opposite leg and I divide it by the hypotenuse, I will always get 0.64. And that's what sine tells me. Sine tells me that for any angle in a triangle, in a right triangle, the opposite leg divided by the hypotenuse has a fixed value. So, and this will all make sense when we start doing some examples, but this is just a big overview of that. So check this out. Now, my calculator also can calculate all this. It's programmed into the calculator. Actually, before we do the calculator, let me show you this table. So back when I was in high school, I didn't have the luxury, here we go, of always having a scientific calculator. The one I had at home was kind of crappy and didn't have trig stuff on it. But I want you to notice that there is a sine, cosine, and tangent ratio value for every acute angle from 1 degree to 89 degrees. And even between, even all the decimals. All right, but the table only gives integer value of degrees. So remember what I just showed you in my little nerd program. The sine of angle A, which was 40 degrees, is 0.64. And I calculated this by hand. But now look at this table. The sine of 40 degrees is 0.64. Right here. 40 degrees, 0.64. Look at the cosine of 40 degrees. Is 0.766 or 0.77. And if I go back to the nerd program, that's exactly what I found. All right? So what that means is that you could do this exact same work for any triangle regardless of the angle measure because you would simply just use this table. So maybe instead of a 40-degree angle, I had a 20-degree angle. Well, the opposite over hypotenuse, or the sine ratio, would be 0.34. And then the last thing, you guys, is you're welcome to use this table, and I'm going to put a link to it on my website or on the Schoology site. But in addition to that, if you have a scientific calculator, as long as you are in degree mode, so you're going to have to either Google or FaceTime me or whatever, and I can help you make sure your calculator is in degree mode. Well, if you put your calculator in degree mode, which I think I didn't. Yeah, I did. All right, sweet. Check this out. Go back to the nerd program, pull up the calculator. If I wanted to find the sine of 40 degrees, it's going to spit out 0.64, exactly what I found. and exactly what I found by simply dividing the opposite over hypotenuse. The cosine of 40 degrees .77, and so forth and so on. So you guys, this, I know it's confusing. This is a big picture introduction as to what these weird words sine, cosine, and tangent mean. And I'm going to do a notes video now that will walk you through the process a little bit more detailed. But before I did that, I wanted to give you a big picture. I hope this makes sense. And of course, if there are questions, all you got to do is reach out, and I'm happy to help you. All right. So anyway, enjoy, and check out the notes video next.